Good morning class. Welcome to the online classes for science of class 8. We were going to the chapter that is sound, and we have seen that what was the sound, how it propagates, how is the way that it is coming out from our mouth, and how we just communicate. Like we have seen our larynx, how that windpipe blows the air and how it comes out and how it reaches the ears of our head, right? So this is what the different parts of the sound. Now we have seen the construction of ear also in the last class, that ear has a construction similar to that of a funnel, right? So the outside structure is what we can see. You can touch your ears and you can see they are stretched, right? They are stretched in the form of a rubber string, and there is a eardrum inside the ears, that is Kankapada, which we have seen in the Hindi also. So the outer part is in the form of the funnel, that is it have a branch like structure, and inside we can see there is a canal through which the sound coming from anywhere, when it get vibrate, that sound is produced, and coming from there it will reach our ears, and through this canal this sound will propagate. So this will enter into our ears through the canal and will reach to our eardrum. So this stretched rubber band has structure of the membrane, which is inside our ears. When it strikes, so it gets a reaction that some sound is coming. So these waves will strike the eardrums, and from this eardrum, the rubber sheet, the sound vibrations try to vibrate it. So these vibration to the inner ear, it will vibrate and will send this vibrations and make as a signal, and it goes to the brain. As it reaches the brain, able to understand that from where the sound is coming. So from like this and this condition, we used to hear a sound. And after that we are going to see what this amplitude, time period and frequency of a vibration means. And we have seen that sound is a kind of a travel, right? It travels in the form of a transverse wave. And what we have seen, that transverse waves is like this, right? This is what your transverse wave. If you want to draw one more wave, you can draw. This is kind of waves like it is traveling. So continuously it travels like this and it reaches to our ears, right? So in this one wave, if you talk about one wave, then it will be like this. This is what one wave is. And if it continuously propagating, it will be like this. Someone more wave will also be there. So this is what the wave. And when these vibrations are done, that is top and the down, when they are moving in the top condition and down condition. So this is what the height of the wave, that how much length it will be propagating in the positive half and how much it is going in the depth in the negative half. So this is what the height of the wave is considered as. So this is doing motion, right? Motion means a moving object. So this is trying to move. So what kind of motion it is doing? It is oscillating. So this motion is said to be oscillatory motion, that is an object doing to and fro motion. Okay, then that motion is considered as an oscillatory motion, or we can say that vibrations means it is getting oscillated. Okay, so now we are seeing that what this means: time period, amplitude and frequency. So you may have read in the earlier classes that oscillation motions have some time, like one vibration takes some time to complete its vibration. So that time is considered as its time period. So time taken to complete this one complete vibration. One complete means like this. If it is completing this vibration, that means that time taken to complete is considered as a time period. Now the number of oscillations completed in 1 second, like if you count 1 second and how many waves traveled, this will be considered as its frequency. So if you take a biggest wave, then it will take a small wave. That means in 1 second the wave cannot travel, right? Number of waves cannot travel, only one wave can be drawn. But if you talk about smallest wavelength, like if you're talking about like this can be drawn many times in 1 second. So if you talk about 1 second, like one, we have drawn two waves. But if you want to draw a biggest wave, like one, we have not completed the one wave also. That means the body, the number of vibrations or the number of waves which are considered to be in 1 second. That means in 1 second, how many are waves going to be traveled are considered as its frequency. So frequency is that the number of oscillations or the number of waves in 1 second is known as its frequency. So this oscillation have its frequency and its unit, like we are measuring the length in the meter or a weight in the kgs or grams. Similarly here the frequency is measured in the terms hertz. It is given as hertz, which is written as like Hz. Okay, so in one oscillations in 1 second is given as hertz. Okay, now what this amplitude means, so the wave when it travels, so it will take some time, right? It will take some time, that is time period. And how many waves are traveling in 1 second was considered as frequency. So now if we talk about a single wave, now see this wave, how much this wave's length is, means how much it is getting in the top direction and in the down direction, how much the length is displaced by this wave in the top and the negative direction, that is considered as a wave. So this top direction and the not means you can say down direction, this displacement is considered as an amplitude. So the amplitude of the wave will be how much it is getting displaced in the down direction and in the top direction. So that is what is its amplitude. Okay, so the amplitude is that the maximum displacement done by the wave. So frequency, time period and the amplitude, we have seen this here, right? So amplitude means the height of the wave travelled by a single wave. So see here, this figures are showing you the amplitude and the frequencies. Like this wave is traveling, that means the wave is continuously traveling. But if we talk about the frequency, this wave is also traveling. So the frequency, whose more it is, we know that in 1 second how many waves are going to travel, that will be having its frequency. So the highest frequency will be of this wave, this is having less number of waves traveling in the second. So this is what the amplitude and frequency means. But what this amplitude and frequency tells us about, any wave which has the highest amplitude, that means the sound is too loud, because sound is traveling in the form of wave and it is getting into our ears. So what is the wave's height is, that is amplitude, how much big wave is coming, that means the sound is that much loud. So the louder the sound will be, so the amplitude of the wave will be that much big or that much large. So sound produces large, that means the wave is very large, that is having a highest amplitude. But if you are talking about louder, means less louder sound, that means the wave is small. So if this is this much small, that means its sound is also very much less, or we can say feeble sound is coming. And here this amplitude is high, so its sound is very much louder. Okay, now frequency, what that means, what is the frequency, how much fast the sound is going. If it is talking about this is going slower than this. If we talk about more larger, that's very more slow. And if you talk about this wave, then this is more slow. So the frequency is highest in the first one, then again second, then again third. So this was decreasing order for the frequencies. So frequency of the vibration is lower than the sound pitch will be low. So amplitude was telling us loudness. Amplitude was given by the loudness. But if we talk about its pitch, then it is given by frequency. Frequency is given by pitch. Frequency is given by its pitch. Okay. So if you talk about the frequencies, then how much the pitch of the sound, how you will be calculating. Like if you are hearing a drum sound, that is blunt, na? This is drum, that's loud, but it is not having high pitch. It's not that much sharp to enter into our ears. That means it is very much loud. That means the wave's amplitude is high, but its frequency is not that much high. And if we talk about a sharp sound, like whistle sound, of your cooker also you hear in your pressure cookers at your home, or the simple whistle which you used to blow by your mouth, there also if you are using, then the sound is very much sharp. There the frequency is highest. So the frequency is low, that means the pitch is very low, the sound will be not that much sharp. If you are talking about highest big wave, that means the sound is very much loud. So the louder sound will be given by its amplitude and pitch will be given by its frequency. Is given by its frequency. So what the frequency will be, that is the fast wave will have its highest pitch. If this wave, then its lowest pitch. And if you talk about the wave's height, then it's louder sound. And if it's a small wave, then it means it's not that much louder, it is feeble sound, very less sound. Got it? So now the audible and the inaudible sounds. So audible means some sounds we know that we used to hear, but some of the sounds we are not able to hear by our ears easily. That means when we used to think of about the earthquakes or the tsunamis. They used to be happen, but whether the sound comes to us, no, we are not able to hear that sound. It is only be able to see. After it happened, we can understand that yet earthquake came or tsunami came. So that means some tremors are there inside the surface of the earth which are not able to be audible to us. Means our ears cannot be able to hear that sound. And if you are talking about like our sound, that means someone is talking to you, you are easily able to hear. That means they are in the range of a audible sound. So you are easily able to hear that sound. That is the audible one. And if you are not able to hear that sound, that means it is inaudible sound. There are different ranges. In that ranges, we can just differentiate one as inaudible sound and one as a audible sound. So audible sound means which we can hear easily. Inaudible sound, this is not in the range of our hearing, so we cannot hear the sound, cannot hear that sound. So there are some frequencies which we can hear. Like if you are talking about 20 hertz, then from 20 hertz ranging to the 20,000 hertz, we can just hear this type of sound. This range of sound can be heard by us very easily. So this is what the range for the audible sound. What that means, that we can hear the sound which are in the range of 20 hertz to that of the 20,000 hertz. So if the sound less than that of 20 hertz or more than that of 20,000 hertz, one was 20 hertz and ranging till 20,000 hertz, right? So range of the sound between this 20 hertz to 20,000 hertz we can easily hear. So this is what the range for the audible sound. And if you are talking about less than this 20 hertz, we cannot hear, or more than 20,000 hertz, then also we cannot hear. So these both are considered as an inaudible sound. These are considered as inaudible sound. Okay. So now noise and music. What the noise and the musical will be? That is, the sound have different ranges. And if you are talking about the range of the sound that are audible to us, that was from 20 hertz to that of 20,000 hertz. So 20 hertz is also audible and 20,000 is also audible. That doesn't mean that we will be happy to hear that 20,000 hertz sound. That is audible, but our ears cannot bear that much sound also. So the range of 20 hertz, that will be pleasant and that will be very feeble to hear. Like small children used to say of very less sound, and we used to keep our ears near to them so that we can hear the sound. That means that is a very feeble sound, but that is very pleasant to hear also. So music, it may be louder or less, but we are able to hear it very pleasantly. So that sound which is pleasant to hear is considered as a music, and the sound which cannot be heard that much easily are considered as noise. So noise is something that cannot be heard by us. So that is in the range of the audible or inaudible, but they cannot be heard by us. So this kind of unpleasant sounds are considered as a noise. Okay. So what is noise pollution? We know that the unpleasant sounds which are coming from our ear is known as an unpleasant sounds. And we know what's the pollution means. Like if you are talking water pollution, that means the unwanted waste when it is mixing with that of a pure water, then it is water pollution. If you are talking about air pollution, that means the gases coming out from the vehicles or the factories, when they are getting mixed with that of the normal air or a breathing air, that means the air gets polluted. So that given that can be considered as an air pollution. That will be considered as an air pollution. So now after that, if you talk about the noise pollution, then the sound of vehicles or explosions, the stop loud sounds or which are not pleasant to hear, which are a kind of noise, this will be considered as a noise pollution. That these sound will try to hurt our ears. That is known as a noise pollution. So what are the harms of this noise pollution? We know that our blood pressure is there. This blood pressure will be increased when there is some anxiousness around us. So when the sound is there, like crackers sound now in Diwali, if it is more and louder, then what will happen, that we used to feel like an anxious, that anxiety will be increased, or we can say that the blood pressure is also increased. So the loud sound may get temporary, or even you can say that he will get a high blood pressure. So high BP problem will be there. Okay, high BP problems will be there, and noise will be there. You can say hypertensions will be there, anxiety will be there, and many more health disorders will be also there. And if you think that you are having a loud sound, that you are saying very loudly or hearing very loudly continuously, That means temporarily or permanently you will be impaired of hearing, means you cannot able to hear. Now you will become a dumb condition will come, deaf like. Okay, so you will become a deaf. So similarly, these are the harms that of the noise pollution you will be seeing around you. Now measures to limit noise pollution is how can you just less, or you can just decrease this limits of the noise pollution, is the harms of the noise pollution. We know that to control the noise we must control the sources of noise, like we are hearing a loudspeakers that are used in our societies, that should be decreased, or the vehicles blowing horns should be decreased, the sound should be decreased. So in our residential areas, like using musics or DJs around us, they should be decreased. Amplifiers should not be used. Use of automobile horns should be minimized. TV music should be at a very low volume, should not be used at high volumes. Across this, we can say that the trees should be morely planted, because planting the trees around our roads or around the houses, the sound reaching that from the traffic will be less, because if trees are there, then the traffic sound will be decreased, because they will be not allowing the air of coming out from the trees, will be not allowing this noise to come into our residential areas, that means the areas where we are living. So that will be not entering into our residential areas. So this can reduce the harmful effects of the noise pollution. So in this way we can just come out from the harm that are produced by the noise. So what is this noise pollution? That is unpleasant sound which can harm us, and to reduce this we should decrease the volumes of our TVs or musics which we are using, or the automobile horns that are used by our trucks or the vehicles, it should be less. So we should plant more and more trees, so that the sound coming out from the traffic should not reach us to our residential areas. So it will make to clean the environment or the surrounding also. So this noise pollution can be decreased. Okay. So these are the points that you have learned, that sound is produced by vibrating objects. We know that the sound is produced only when the object get vibrated or any other object is striked on it, then only the sound is produced. And human beings, how we are going to produce the sound? That the wind pipe is there from where the wind is blown, and this wind will try to make our vocal cords, small two vocal cords will get vibrated, through which the sound is produced. And we know that the sound travels through medium, right? It needs a medium to travel. It always needs a medium. It may be solid, liquid or gas, but it needs a medium to travel. Similarly, it cannot travel in a vacuum. Vacuum means space where the air is not present, but less low pressure layers are used. So there the sound cannot travel, like in our space the sound cannot travel. The eardrum, that is inside our ears, the stretched form of the thin membrane, that senses out the vibrations of the sound. It sends the signals to the brain, and this process is called hearing. So this signal, when it enters into our brain, we get that we are hearing something. And we have seen some properties of the sound waves also, that waves gets vibrate. That motion is considered as an oscillatory motions. And the frequency, that is the number of oscillations moving in 1 second, are considered as an frequency, and it was given by the unit hertz, Hz. And what was the amplitude? That is the height displaced by the wave, that how much the wave is of height, that is considered as its amplitude. What is the amplitude will be? It will be its loudness. So how much the amplitude's height will be, that means the waves is more amplitude, that means the height is more of that wave, so sound will be more loud. And if you take a small height with small amplitude of the wave, then the sound is also very less. Similarly, pleasant sounds are also of their ranges, and unpleasant sounds are also there in the ranges. The unpleasant sounds are considered as its noise. So excessive or the unwanted sound that leads to the noise pollutions, they can cause various health disorders also. So to minimize this noise pollutions, there are various attempts we have seen, that we should not make the more sound by our TVs or the musics in our residential areas. We should not use a high loudspeakers of volumes. We should not use the automobile horns that are producing the noise in the roads. And we should also plant the trees, so that the residential areas cannot have the sound coming out from the traffic. And similarly, plantation on the roadsides should be done to reduce the noise pollution. So these are the points that we have learned in this chapter. So in the next class we will be seeing a recap for this chapter, and after that we will be going to the next chapter. So thank you class.